Hey everyone, so we're going to talk about PathoDX Strep typing with the PathoDX Strep Grouping Universal Kit. So this kit is designed to identify beta hemolytic strep of the Lancefield groups A, B, C, F, or G from either primary culture plates or broth subculture. You can see here all the different kinds of strep. These are all beta hemolytic, although it's difficult to see on here. Usually group B strep has a larger colony morphology than the rest of them. So latex particles coated with a Lancefield antigen-specific IgG antibody react with the antigens on the bacterial cell wall, and those antigen-antibody complexes can cause visible agglutination. So here you can see that all the antigen-antibody complexes are agglutinating, causing clumping and agglutination. So this is, if it's grainy, it's a positive agglutination. If it's smooth here and there's no visible agglutination, that's a negative. Some tips for larger isolated colonies like Group B, you use about 1 to 2 colonies, but for tiny colonies like Group F, you can use 10 or more. But always make sure you do your catalase testing first, because you can get false positive reactions with Staph aureus since the bacterial antigens may bind to the Fc portion of the reagent antibodies for Staph aureus. And Listeria monocytogenes share similar antigens with Group B Strep A galactiae. They look very similar on the plate. They're both with small zones of beta hemolysis. However, Listeria monocytogenes is catalase positive and also a gram-positive rod, whereas Group B Strep A galactiae is a gram-positive cocci and it's catalase negative. And you can also get a false positive if you use too many colonies, because it's just there's so many colonies that they're actually clumping together just because there's so many of them, or if the colonies are really mucoid, they're difficult to emulsify when you're mixing them up, and it may look like agglutination, but it's actually just chunks of the mucoid colonies. You can get a false negative if you don't use enough bacterial colonies too, and bacterial colonies must be 18 to 24 hours old, and this is a good rule of thumb for pretty much any kind of biochemical testing, that the colonies have to be between 18 and 24 hours old, otherwise the results get a little wonky. The reagents, all reagents have to be used at room temperature. There are reagents that have to be stored refrigerated, so you have to pull them out of the fridge and let them warm up to room temperature for 15 minutes to a half hour or so until they get to room temp. Only the latex reagents and the control reagents, when you're doing your positive and negative QC, have to be refrigerated. The remaining reagents, the reagents 1, 2, and 3, can be stored either at room temperature or refrigerated. And as always, check your expiration dates. And so for the next part of this, we're going to be actually showing you how to perform the testing. So to perform this, you can see all the reagents are out here, and you can see the red top, the pink top, the orange top, the blue top, and the purple top there, and those are all the latex reagents for A, B, C, F, and G. The red top is A, the pink is B, etc., etc. Then you have the 3 reagents. You can see there's a reagent 1 that she's holding right there. There's the reagent 2, which is the blue top in the back, and reagent 3, which is the green top. So first we're going to take 2 drops of reagent 1 and we're going to put it in a small test tube, small clean test tube. Then 2 drops of reagent number 2. Remember, this is not a sterile test, this is a clean test, so we don't have to be sterile here, it just has to be clean. So that test tube does not have to be sterile. So 2 drops of reagent 2, and then she's going to mix it up a little bit. Next she's going to take several colonies, and you can see they're kind of little, so she's going to take a couple stickfuls there, and she's going to emulsify it into reagent 1 and reagent 2. You want to take the stick out right away because the stick may react, so you don't want to leave the stick in the test tube. Now she's going to take reagent 3 and she's going to put 4 drops of reagent 3 into the test tube. When reagent 3 goes in, it reacts with everything else, and it's a heat producing reaction, and you'll be able to see it boil, so just make sure you don't touch the bottom because you don't want to burn your finger. Okay, so now you want to make sure that these reagents A, B, C, F, and G latex reagents are extremely mixed up. The latex beads have a tendency to sink to the bottom of these, and so you check the bottom to make sure you don't have any blue latex stuck to the bottom. It's kind of just like paint. So she's going to put a drop of A onto the test oval 1, a drop of the B reagent into 2, and we can go ahead and speed this up a little so you don't have to watch the whole thing. Okay, then she's going to take a drop of her suspension, bacterial suspension, and she's going to put a drop each into each test oval. I always like to put the latex down first because I don't like to put the drop of the bacterial mix first and then risk splashback. Also, because then you contaminate your reagent. Use the flat of your stick when you are mixing these, and make sure you mix all the way to the edges of the test oval. It makes it ever so much easier to see the agglutination if it's all spread out. If you leave it just as a blob there, it's really difficult to see the agglutination. So she's using the test or the flat of the stick. We'll go ahead and speed her up here a little bit. Okay, and so now she's just going to rock it back and forth and look for agglutination. Don't be shy with this. Rock it hard, because you really want to make sure that you're spreading everything out to get those antigen-antibody complexes there. And you can see she's saying that in test oval number 5, which is group G, she's starting to see a little bit of agglutination. So she's going to continue to rock it. You rock it for at least a minute or until you see obvious agglutination. And here you see that there's the agglutination for group G strep. Okay, thank you guys so much for watching.